welcome to this video 5-C. Today we're going to talk about how to analyze functions and their derivatives using a calculator for those calculator active problems. You're going to go ahead and need your calculator. In this video I will be modeling how to analyze functions and their derivatives with a TI Nspire, but if you have any graphing calculator, as long as you can graph the function and look at it, our conversations will be applicable. I'm going to go ahead and look at our first example here. It says, let f of x be a twice differentiable function on the closed interval 0 to 5, whose derivative is defined as f prime of x equals natural log of cosine of x plus the square root of x. Okay, this is a gnarly looking function, and I do not want to analyze this at all by hand. So what I'm going to want to do is I'm going to want to either define this in my calculator or go ahead and graph it. Now note, it's worth noticing that we have f prime. This is an f prime graph. So I'm going to go ahead, I'm going to go into my graph, or into my calculator, and I'm going to open a new graph, and I'm going to graph this. So we have the natural log, so natural log of, and then we had cosine of x plus the square root of x, square root of x, and I'll hit enter. Okay, and there is my graph. So notice it's only defined at 0 to 5, so I'm going to adjust my window. I'm going to go menu, window, my settings. Really, I only want to look from, let's say, -1 to 6. Okay, and let's maybe get a little bit better on our y-axis here. Let's do the y scale. I don't know. Maybe let's do -3 to 3. I think that would be fine. Okay. All right. So here is our f prime graph, and we're going to go ahead and answer some questions now about this function. So A, at which x coordinate does f of x have a relative minimum on the interval 0 to 5? Explain your reasoning. Okay, so we know that minimums occur when we travel from a decreasing to increasing. So I am wanting to know, okay, where's my function decreasing? Well, it looks like my function's decreasing here at these 2 points, okay, and then we change to increasing up here. So I'm going to analyze my graph. Menu, analyze my graph, and I want to analyze this 0 right here. Okay, so 3.599. That is a relative minimum because I'm changing from decreasing to increasing. Okay. Now, if you wanted to go ahead and make a sign chart about this, you could go ahead and do this. You would also want to go ahead and find this 0 here, which is 1.996 or 997. So I'll go to my graph, and I'm going to go ahead and make here an f prime graph. So I'm starting at 0, and I have 1.997. And then my other graph, or my other point was 3.599, and we ended at 5. Okay, so here's my f prime chart. That's where f prime is 0. And looking at it, we go positive, negative, positive. So positive, negative, positive. Okay, so all right, so where do we have a relative minimum? Well, when we change from negative to positive. So we can say f has a relative minimum at x equals 3.599 because f prime changes from negative to positive. There you have it. Pretty easy. All right, next question. On which intervals is f of x increasing in 0 to 5? Okay, so I'm going to go ahead and I'm just going to read my sign chart. Thankfully, I already made it. So from 0 to 1.997 and 3.599 to 5. So we can say f is increasing on 0 to 1.997, union 3.599 to 5, and the reasoning, because f prime is greater than or equal to 0. Okay, there you go. Pretty straightforward. All right, next part. On which intervals is f of x concave down in 0 to 5? Concave down. Well, that happens, looking at my graph. Okay, this is the first derivative. So concave down happens when f double prime is negative. So this is f prime. F double prime, that's going to be the slope of this. So what I need to know is okay, where are my maximum? Where's my maximum and where's my minimum here? Because that's where we change. We are increasing, decreasing, increasing. So what I'm going to do is I'm again going to analyze the graph, and this time I want a maximum. Let's say somewhere over here to here. Okay, so there is my maximum, 0.662. And then I also want a minimum. So analyze graph, my minimum here. Okay, and we get this value, 2.840. Okay, so again, I can go ahead, I can make a f double prime number line this time, f double prime, 0 to 5, and our first f double prime equals 0 value was a maximum that was 0.661. So 0.661. And then our other one was 2.840. 2.840. Okay, so f double prime. It was increasing, so f double prime was positive, then the graph was decreasing here, so f double prime was negative, and then it was increasing again. Okay, so where is f of x concave down? Well, that's when f double prime is less than 0. So it looks like from 0.661 to 2.840, and you can see that visually here. From this point to this point, our function is concave down. Okay, so we'll go ahead and say f is concave down on 0.661 to 2.840 because f double prime is less than 0. And there you have it. There you have it. Okay, at which x coordinates does f of x have a point of inflection? Well, whenever we change concavity, it looks like it happens 2 times at both of these values. So we can say f has points of inflection at x equals 0.661 and comma 2.840 because f double prime changes signs. Awesome. Very, very straightforward. Okay, and then E. On which intervals is f of x both decreasing and concave up on 0 to 5? Give a reason for your answer. Okay, so we're going to go ahead and look at our graph. Decreasing and concave up means that f prime of x, okay, is negative, and concave up would be increasing. So here's where our function's decreasing, and where is it concave up? Well, from this point to this point here. Okay, so that looks like 2.840 to 3.599. That's where it is decreasing, and concave up. It's increasing there. Okay, so we can say f is both decreasing and concave up on 2.840, comma 3.599 because f prime is less than 0 and f double prime is greater than 0. There you have it. Pretty straightforward, pretty straightforward. Okay, here is a second example. I would like you to go ahead and pause the video and try this example on your own. Looks like we're missing a variable here. And then also 2, I know that this is missing a minus 2. We want to shift this down 2 units, okay? So please pause the video. I'm going to show the solutions here in a second. But we just want to find out for which x values does g of x have a relative minimum on the interval -2 to 4, and on what intervals does g of x decreasing on -2 to 4. Justify your answers. All right, go ahead and try that, and I'll show you the answers here in a second. All right, here are the solutions to example number 2. G has a relative minimum at x equals -1.686 because g prime changes from negative to positive. And g of x is decreasing on the interval -2 to 1.86 because g prime is less than or equal to 0. Now, how we determined this, again, was we used our calculator. We went ahead and opened up a new calculator. As soon as you switch problems or you're starting to get too cluttered on a graph, I recommend opening up a new graph. Sorry, I should do a new graph here. And then we went ahead and we just plotted that function. So Control E. Make sure if you were having issues graphing this, that you use the function E. Use the function E and not the letter E. If you use the letter E down here, you're going to get an error. So this was x minus sine of x, and then we had a -2. We shifted it down 2, and here is our graph. Okay, you need to go ahead and you need to analyze your graph and find the 0, which happens here at 1.686. So notice f prime is negative and then it's positive. Decreasing function and then it's increasing. 1.686 is a relative minimum. Also, our function is decreasing on that interval -2 up until this point because f prime is less than or equal to 0. All right, there you have it. Okay, I have one more example to go ahead and show you guys here. Here is number 3. They say, let h of x be a twice differentiable function whose derivative is defined as h double prime of x, which equals e to the power of -x plus cosine of x. Okay, so they want to know on what intervals is h of x concave up in -2 to 4. So note, I'm going to do the same exact process here, except this time I have a second derivative. This is the second derivative function. So I'm going to go ahead and graph this. We'll go ahead, open up a new graph, and we'll graph our function e. I keep hitting second function. I just want the original. E to the power of -x plus cosine of x. Cosine of x, okay. And here is our function. So -2 to 4. -2 to 4. I'm going to go ahead and I'm going to adjust my window. Make sure that you're aware where your window starts and where it ends, because, you know, they can go ahead and have extra stuff there. So -2 to 4. Okay, so there's my graph. Okay, and looking at the questions here, where is it concave up? Well, that's where g prime is positive, concave up. Okay, so this is g prime. So where is it positive? Well, starting at -2 all the way up until this point. So I need to know where that that point is. So here's my 0. Okay, 1.746, and so we have -2 to 1.746. Okay, and we can say h is concave up on that interval because h double prime is greater than 0. All right, and the last question, D, where does h of x have a point of inflection in -2 to 4? Well, again, that's when our concavity changes. So looking at our function, that's going to change right here at 1.746. So h has a point of inflection at x equals 1.746 because h double prime changes signs. All right, that'll do it for this video, and that is how you analyze functions with a calculator. See you next time.